the last session, we were loaded the labels data into the data frame and viewed them. Now in this session, we are going to build and train the model. So as we are using CNN, we will take the layers such as conventional 2D, Maxpool 2D, flatten, and then we will apply the dense layer and the final layer. So let us go through this one by one. So we are taking the model as sequential. The model is sequential. As you can see here, that the building a sequential model, we have taken conventional 2D layer. We have set the number of filters as 64. You can play around the number of filters, kernel size and activation function, because it can happen that the accuracy of this model can be improved. This is called the hyperparameter tuning. So the first layer, we need to pass the input shape 224 by 224 by 3. After that, I have applied Maxpool 2D layer and with the full size of 2 by 2. Find out the most dominant feature in a 2 by 2. Similarly, after that, I have applied the conventional 2D and Maxpool 2D again and again with a different number of filters. That is the filters 16, 8 and so on. Similarly, you can add as many as number that you want as it gets you higher accuracy. After completing the conventional layers or the Maxpool layers, we will use flatten layer to this data, because now we need to apply the dense layer. We will flatten this data by adding flatten layer. Next, we will add a dense layer with 128 neurons, activation function as ReLU, and kernel regularizer of 12. Similarly, adding one more dense layer which is of 64 neurons, activation function is ReLU, kernel regularizer 12. Final layer will contain the number of neurons as the total number of classes, which is 3. Also, that is a multi-class classification function. So the activation function for the last layer of the output should be softmax, because softmax gives us the probability of classes. After creating this architecture, now let us complete this model as well. As we are working with these images, we will take the loss as categorical cross entropy. We are using an optimizer Adam with a learning rate of 0.0001 and matrix article is the accuracy. Now we are printing the summary of this model.summary. Let's see the summary. So here you can see the summary of this one. So we know that the model is sequential. The first layer is conventional 2D with the output of 220, 64, which equates to 4864 parameters. Similarly, you can see that Maxpooling layer conventional 2D, the second layer, Maxpooling second layer, and so on. After the flattened layer, we have a dense layer, then second and third and final output here, which is 3, because we are working on only 3 classes. In the summary of this model network architecture, we find out the total params 1,62,619 and trainable parameters 162,619 and non-trainable params are 0. The next step would be to split the data into training and testing and to split that data into training and validation. So here we are using split function from sklearn and splitting our data. So after running this and split the data into train and test, and then further into train and validation data. And next we will fit our model. So in order to fit our model, we will need to define the number of epochs. So for our model, we have taken 100 epochs. It is a model which requires a very high computation power. So 100 epochs, it will take some time. Similarly, I have taken the batch size as 128 and I have fitted this model and saved that in the history. So here you can see that by fitting the model, I have called the X train data and the Y train data, batch size, epochs, and the validation data which we have submitted. You can try this model using more number of epochs and the batch size for high accuracy. Also, you can see during each epoch how the model is performing. So now let us run this and see how much time it will take. As you can see here, each epoch will take around 17 seconds, and you can see that it is also printing the loss, accuracy, the validation loss and the validation accuracy. It will take long time for execution. You can just need to get into edit section, go to the settings, and you can change your hardware accelerator as TPU. So it took me around 1.5 hours for the execution process. As you can see on this model, we can see the final accuracy is 98.44 and the validation accuracy is 0.75.